Now in lesson 2 of chapter 3, we're going to take a look at the slope-intercept form in some detail. These are the objectives if you'd like to check them out, but we'll be moving on. And as you start the notes of background on slope, you're asked, what is slope? Well, we talk about the slope of a roof, and it would be a ratio, and we use the letter M, lowercase letter M, to designate slope, a ratio in a graph of y units over x units, and y is in a sense the rise, and the x unit is the run. So that's basically what slope is. Now we have negative slope, and let me give you some background on that. If the graph starts low and goes up, this is positive slope. If the graph starts high and goes down, this is negative slope. And if the slope is a horizontal line, we say that's zero slope. And if the slope is a vertical line, we say that slope is undefined. All right, some background on slope. Hopefully you have all this in your notes. Again, a little more background and calculating slope. Now, we have a slope formula, but looking at the graph, you can also pick out the slope by making what is called a right triangle, where you have a right angle here somewhere. Get my pen working. There we go. This is a little right angle. And if you have a point on the grid and another point on the grid, if you count the units, so what is our run here? Well, 1, 2, 3, 4. And then now what is our rise? 1, 2, 3, 4, 5, 6, 7, 8. And then we usually simplify that as 2. So the slope of this line is 2. Now, if you recall from before, this was our y-intercept. And slope of 2 is really 2 over 1. If there's a 1 in the denominator, we don't write it. So this is going over 1, up 2. Okay. And there are many right triangles that you could possibly make, but that is slope. And again, since you're going to the right 4, which is positive direction, and up 8, positive direction, this gives you positive slope. Now, if you started here and went over to the left, this would be a negative 4 for the run, and then going down in this direction would be negative 8. That would still give you a positive 2. So these are background items relating to slope, looking at the graph to pick it out. Now, another way of finding the slope is when you have two ordered pairs, and we would use the slope formula, which is given right here, and what I've written. So we're going to designate one of these ordered pairs as the sub 1s and one as the sub 2s. And the protocol is you take y sub 2, which is a 5, a minus is in the formula, and you go to the other y sub 1, or the other y, which is a sub 1, which is a 2. Now you're going to do x sub 2, which is a 3, minus is in the formula. But now notice that our other x, which is the sub 1, is a negative. So first we would put that in a parenthesis as a negative 1. And notice what happens now. The opposite of a negative 1 makes this a plus. So our top becomes a 3, and our bottom becomes a 4. So our slope is, and as we look at this a little bit, I'll move it down, 3 over 4. Now, if you reverse this and had the other be the sub 1s and the sub 2, you would end up with a negative 3 over a negative 4, and it would still come out to a positive 3/4. Okay, let's go on. This is an important one. In your notes now, for example 2, they're asking us to use these 2 points and figure out the slope. And then later they're going to show us the graph of this. Let's raise it up just a little bit more. So our slope is y sub 2, and we're going to use a 1 here, minus y sub 1, which is a 3. If you develop a little pattern, it works out very well, and then 5 minus the 1. So this is going to become a negative 2 on top over a 4 on the bottom, which simplifies to a negative 1/2. And if you counted it from this point, going in a negative direction, then a positive direction, you get the same results. Again, starting high and going down as you go from left to right, this is negative slope. Okay, again, you're going to do practice and certify on this and try it out on your own. Now, here they're introducing horizontal and vertical lines. We gave you the slope of these earlier, but let's see how they figure it out. Now, notice if we use these 2 values, this is example 3, and then put it into our slope formula, and you should copy this down, you end up with 0 over 7. Now, sometimes on a quiz or a certify, they'll give you a problem like this, and you'll say m is 0 over 7. They're going to count that incorrect because this is not simplified. What is 0 over 7? And the answer is it's 0. So the slope of this horizontal line is 7. And I also want you to write this down, that the equation of all horizontal lines is going to be y equals b. That's the special equation for horizontal lines. And if you remember, our b is our y-intercept. So in graphing something like this, you would put a dot at your y-intercept, and then any other point along it, that same horizontal line, and the equation would form. And there is, again, the equation in its form, y equals b. B being the y-intercept. All right, let's go on. Now, you're going to write example 3, and the question is, find the equation and slope of the horizontal line going through this point. Well, here you're going to go to your toolkit, and you know the equation of all horizontal lines is y equals b, and the ordered pair can sometimes be written as a comma b, and if b is what we need. We look at the ordered pair, and in the B position is a 5. This equation will be y equals 5. And of course, this is what they have. And we know the slope of all horizontal lines from our toolkit now is 0. In example 4, to include in your notes, we want to find the equation and slope of a vertical line going through point 3, 2. Well, again, we're going to reach into our toolkit and get that x now equals a, which is the general form for the equation of a vertical line. Again, our ordered pair is a, b. And then once we know what the ordered pair is, and they want a vertical line going through it, our a value is 3. So the equation becomes x equals 3. And we know the slope of all vertical lines from our toolkit is undefined. And again, through repetition, writing these formulas out, hopefully you pick up on skill and then later mastery. And we'd like you to include a little sketch of this. Had a little phone call coming in. Here's our next background item. Again, we reviewed for this a little bit. The Slope-Intercept Form. And you're going to write y equals 5x minus 7. Now, if you had a set of ordered pairs, you'd figure out the slope was 5. Now notice in the formula that we've been giving you for slope-intercept, we're saying it's y equals mx plus b, and this is called slope-intercept because here they're giving you, when this equation is solved for y, the slope and the y-intercept. Ooh, 2 good points. So again, something to star, but it would go there actually. All right, this is background. Now we can use this in helping to develop a graph of these, keeping in mind there is a special form of this for the horizontal line, y equals b. Okay, let's go on. Okay, in your notes, example 5, they're asking us to take this equation and follow along, write it up, negative 2x plus 3y equals 6. That's in standard form, and now solve for the letter y. So 3y, I'm going to transpose this to this side, becomes positive, and then divide everything by 3. And I now get y equals 2/3 x plus 2. Well, they're asking us find the slope. Well, our slope here is going to be 2/3. And our y-intercept, once we found the b, is going to equal 2. Now, we can use this information to graph. And let's check it out because they have it done for us here with the proper grid lines. You're going to just sketch it in your notes. So you're going to put a y-axis and an x-axis, straight as you can be. Mark off 2 spots this way, and that will be your y-intercept. That is your 2. Now you know your slope is 2 over 3. So from this point, you're going to go over 3. 1, 2, 3, mentally. And then that's your run. Then you're going to do your rise. 1, 2. And it brings you to this next point. Now, in some cases, you'll have to know what is the ordered pair of this point. Now, the ordered pair of the y-intercept is this. And then you go over 1, 2, 3, and then 1, 2, 3, 4 to get this ordered pair. So this is a shortcut. Here we didn't have to make a t-chart. T-chart's a backup, but using this special technique to graph. And remember, if it's positive slope, the graph will look like this. I've seen some people with positive slope, they just did it wrong and had the graph go negative slope. So be careful of that. For example 6, write that. We will do another to build up your background and experience. So the equation is x plus 2y equals a negative 6. Again, it's in standard form, so we're going to solve for y. 2y, transpose the x on this side, it becomes a negative x, and our negative 6 stays there. We're going to divide both sides by 2, and I'll put a 1 there for calculations. So this now becomes y equals a negative 1/2 x minus 3. So our slope is going to be a negative 1/2, and our y-intercept is going to be a negative 3. So let's use their graph also. So we're going to go to our y-intercept, which is a negative 3, and put a dot there. Now, I like to do it this way. I do my run first. There's other ways, but I do the run first, which is negative. So a negative 2. Over negative 2, I get a dot there, mentally. And my rise is 1. I go up there. And there's my second point. Now, can you also go down 1 and over 2? Absolutely. That's another way of doing it. But again, we're not using a t-chart to get points. We're using that special way of having an equation in the slope-intercept form, and I'll repeat it, y equals mx plus b. Find the slope, find the y-intercept, plot the y-intercept, and from that point, you plot your slope. Rise over run. If it's negative, it's going to rise from the left, and as you go to the right, go down. All right. Now, from example 7, they're giving us something rather easy. So here, they're giving us the y-intercept, and they're giving us the slope. And they want you to put this in slope-intercept. Y equals mx plus b. So all you have to do is substitute for the m, which is 1/2. Need to include the x. And then here you don't put the 0, you just put the negative 2. And there is hopefully something rather easy. Again, if they're giving you the y-intercept and they're giving you the slope, it's easy to put it in this form. Let's go on. Now I'm going to add a little bit on to this section 2 of chapter 3, Learn, where for some of you that have a graphing calculator and know how to use it, it will be useful to see what a graph may look like. But for others that don't, here is a free graphing site online. So if you go to the address bar and type in Desmos, DESMOS.com, click on that, and then this comes up. And it's free, as I mentioned. You click on Graphing Calculator. And I'm only showing part of the screen here. But if you go over to this part here and you type in an equation like we had, y equals 2x plus 3. Oh, went on the wrong line there. Let's see. Plus 3. I don't want anything over there. And then if I go, once again, you don't see the full screen. So looking at the graph, there's your x-axis, your y-axis, and then you'll see the intercept. The y-intercept is at 3. Your slope is over 1 up 2. It's a nice way to see using some official graphing techniques at this free site. All right, we'll keep this a little short and wind it up.